Once we've worked out the variance covariance matrix, the question then arises, to what use can we put the matrix 2? And a logical extension here of the analysis is to work out the portfolio mean if we knew what the returns were on the portfolio, and if we could weight each of the assets in the portfolio, then this would allow us to construct an estimate of the portfolio mean and portfolio variance. So if we took this variance covariance matrix and set it up in a separate spreadsheet, a separate worksheet, each of the weights here represents 1/6 or 1/6 of the overall portfolio. So each of the assets constitute, just for simplicity, each of the assets constitutes 1/6. And if we take the sum of the weights, of course, they must come to 1. And also for simplicity, we assume that the returns on each of the assets, which is clearly not going to be the case, but each of the returns is 10%. To estimate the mean return of the portfolio, relatively simple. We take this vector here of returns and multiply the vector, the 1/6 array, by the 6/1, 6 rows, 1 column array. And of course the answer has got to be 10%, because equally weighted and each of the asset returns is 10%. To get the variance of the portfolio given these weights, we use this representation here. So we take the variance covariance matrix, that's this matrix here, and we multiply that by the transpose of the weights, and then by the weights again, and that will produce the variance of the portfolio. So in this, using this code here, we take mmult and mmult again, because the arrays are being multiplied in sequence, and we take the transpose. So we take the transpose of this, transpose of the weights, and it is multiplied by the variance. So we take the transpose of the weights are transposed, and we multiply by the variance covariance matrix, which is this set of cells here, close brackets, and then the combination of these two, the product of these two, then gets multiplied by the weights again. So we take the weights one more time and we close off the brackets. And with an array function, to make the estimation, if you hit return, you probably won't get a result. But if we hit return, we get, well, there's two issues. The transpose wasn't put in properly. Let's hit return, nothing happens. Transpose S value, it doesn't work. To make it work, it's shift, control, enter, return. And so this is the variance of the portfolio. To get the standard deviation of the portfolio, we just simply take the square root. So we take this value, put to the power of 0.5, we get the square root to express this as percentage. We get 17% and adjust for decimal places. So 17.25%. So what we've worked out is the return on the portfolio, and we initially started with returns of 10% for each of the assets, and each of the assets are equally weighted. There are 6 assets in the portfolio. Each year we assume very simplistically as having an equal weighting. We can see that the return on the portfolio would be 10% and the variance of the portfolio 2.97%. To go from the variance to the standard deviation, we take the square root, and a simple way of getting the square root is to put the variance to the power of a half, or 0.5. If we go back to the initial spreadsheet and took the initial weightings, so initially we did work out weights based on market capitalization values. We could copy and paste those weights in. So paste special values and transpose, and we notice that the return still remains the same because we very arbitrarily imposed 10% return on each of the assets. If we go back and then find the mean level of return, the average return on each of the assets, and just paste special values, okay, we get a mean return then on this portfolio of 21%, and we have a variance of 6.42 and a standard deviation of 25.34%. In making the estimation for the variance, we took the transpose of the weights. So we transpose the weights here in blue, multiplied by the variance covariance matrix, so that's what's in green, and then followed up by a second matrix multiplication of taking the product of these and then multiplying that in turn by the weights. So the weights here given by the I4 to I9 cell reference.